Okay, so I will be explaining the KNN algorithm in a very simple way. So, KNN stands for K nearest neighbors. Now, this algorithm was developed by Evelyn Fix and Joseph Hodges in 1951. So that's very long time ago. And it was further expanded by Thomas Cover. Now, KNN is a very popular algorithm in machine learning because it's super simple supervised learning algorithm which can be used for classification and also regression. Now we'll see how it works. Okay, so imagine humanity discovered an alien that looked like this. And this alien lays eggs of 3 different colors based on its size and weight. Now let's say we have the data set of this alien species and what color of what eggs they lay. So we have the data set of 2 variables, size and weight. And when we plot the data set, we get something like this. Okay, so what this plot is telling us is that suppose an alien's weight is this and size is this, then the color of the egg that it lays is green. So let's say now we have a new such alien. We know the size and the weight of it, so let's say the data point is here. Okay, so now what the KNN algorithm does is it classifies this new data point to either red, blue or green. So how does it do is, first we choose a particular value of k. Let's say k equals 3. Then the algorithm checks for the nearest neighbor. So the nearest neighbors, as we can see, is this point, and this point. So when we draw the boundary, look like this. And the next step, what the algorithm does is it checks what's the majority, which data point is a majority within this boundary. As we can see, it's red. So in the next step, the algorithm classifies this unknown point as red. So this new data of this new alien which was observed of this particular height and weight is it lays. And now let's say our new data point is over here, and similarly the algorithm checks for the near 3 data points that are nearest to this new data point, and we can see it is this point and this point and this point. So when I draw the boundary, the majority is blue, so the algorithm classify this point as blue. Now another example, let's say the point is here, let's say. Okay, so let's give the value of k as let's give the value of k as 7. So the 7 nearest data neighbors of this new unlabeled point, one is this, another is this, 2 and 3, 4, 5, then 6, and I guess this is the closest point. So when we draw the boundary, now the algorithm checks which is the majority number of data points, and as we can see, it's red, so the algorithm classifies this point as red. Now the value of k can also be 1, now let's suppose the data point is over here, let's say. As clearly we can see, this is one point that is the closest neighbor to our unknown data point, and since k is equals to 1, when we draw a boundary, it looks like this, and it classifies it blue. So this is how the KNN algorithm works. Now one problem is that in choosing the value of k, so there is no proper method for that, so we gotta choose it based on. So we have discussed how the algorithm works. I gave a very simple overview of how it works, and now we'll discuss how the algorithm, how to find the nearest neighbors. Okay, so how does it find this? It calculates the distance between the unknown point and the training point. So okay, so it is done in 2 ways. So one way is in the Euclidean method, and the second way is Manhattan method. So in Euclidean, suppose here we have the sample point is over here. Let's say it's x1 and y1, and the training point is over here. Let's say it is y2 and x2. So in Euclidean, the distance that we calculate is this. So how does it calculate? So we have the simple formula. So d equals root of x2 minus x1 squared plus y2 minus y1 the whole square. Simple Pythagoras theorem. And this is the Euclidean way. And now in Manhattan way, we calculate this distance d1 plus this distance d2. So it is d, calculate its x2 minus x1 plus y2 minus y1. So any of this method can be used for calculating the distance between the unknown point and our training points. And what the algorithm does is it calculates the distance between all such points and selects the k nearest points. So that's how the algorithm checks for the nearest points. Now we'll discuss the pros and cons of this algorithm. Of k and n. Okay, so what are the pros? So the pros are: 1, it is extremely easy to implement. The second is, this is lazy learning. Okay, let's mark it as red. Learning algorithm. So what this lazy learning algorithm means that it requires no training prior to making real-time predictions, which make k and n algorithm much faster than other algorithms that requires training. Example, SVM, linear regression, etc. So it doesn't require training. Now the third is we can seamlessly add new data. So why? Because we don't require any training. So since we don't require any training for making the predictions, we can add this new data as we want. Now the fourth pros of this KNN algorithm is that there are only 2 parameters required. So what are those 2 parameters? One is k and the other is the distance function. Which is either Euclidean or Manhattan. So we just need only 2 parameters for this algorithm. Now these are all the pros, and now we'll discuss the cons. Okay. The first con is that it doesn't work good for higher dimensional data. So why it doesn't work good for higher dimensional data? Because with large number of dimensions it becomes difficult for the algorithm to calculate the distance in each dimension, so the complexity increases like that. By the way, in our example we have showed only 2 features, which is size and weight. So if we have more than 2 features, so this plot will be multi-dimensional. And the algorithm works on that in the way we have described for this. So now let's come back and what's the second con of this algorithm? It has high prediction cost for large data sets. So again, it has high prediction cost for large data sets, because in large data sets the cost of calculating distance between new point and each existing point becomes higher. So the cost of prediction for a large data set will be high. And the third con is doesn't work well for categorical features. So it doesn't work well for categorical features because it's difficult to find the distance between dimensions with categorical features, because difficult to find distance between dimensions of categorical features. So these are the cons and these are the pros. So this is a very simple algorithm in machine learning for classification and also for regression. Now next we will look into the implementation of KNN algorithm in Python.
Okay, then we will continue with the implementation of KNRS Neighbour with using Python. So first of all, we have downloaded the data from the internet that we can work with KNN. So it's a data from Kaggle. So we have this dataset. So okay, we'll import the libraries that we're going to use for our implementation here. So we have pandas, seaborn, and matplot, numpy as necessary. So then we'll read the data, the classified data. It's in our folder. Then this is the data frame. We can use it using pandas to read the data, and this is how the data looks like. So here we have multiple features and independent features, and our output feature is the target class, which is here. So we have to either classify it to zeros and ones. Then now the problem with all these features is the values may be of different things, so we'll make sure to standardize all the variables. For this we do what we do is that we apply a standard scalar, and apart from the target class, this one, we will apply the standard scalar on all of these features. So for that, we're going to use a standard scalar from sklearn. So if we see the standard scalars documentation here, it will be processing the data in this manner. So like we will be giving in the data and it will scale. So how we do is like centering and scaling happen independently on each feature by computing the relevant statistics on samples in training set. Mean and standard deviation are then stored to be used on later data using transform. So we will be applying the standard scalar, and then we will transform our data. So standardization is of a dataset is common requirement for any machine learning estimators. Yeah. So they might behave badly if individual features do not more or less look like standard normally distributed data. So this is why we do it. and then we can continue. We'll perform these things. So here we have applied it, and you can see that we are fitting the data with the scalar function, and we drop the target class because that is the output feature that we want. So we won't be including it in our scalarization of the data. So we can transform the data, and what we get here is the scaled features, which is here. Then the data frame looks like this. After the transformation, basically all the values will get transformed based on the standard normal distribution of the particular data. After doing this, the data frame is here. Then next, we have multiple data features, so we'll try to see visually how they look like using pair plot. Like we'll do a pair plot, and after we run this, it will take a little time because our dataset is fairly large. So by running the pair plot, we get this data, and we can see the result here. So after that, we can like we can just split the dataset into train and test part using train test split from sklearn itself, and we can apply KNN using it. So okay, we will be using KN Neighbour classifier from sklearn, and here we're just going to use k equals 1. Like it doesn't make much sense, but we'll get the optimum value of k by running some algorithm. So we have the model KNN here, and that is Neighbour classifier, k Neighbour classifier with n equals 1, k equals 1, and we have fit the model using our train data. Then we can use it to predict. So we can see our prediction and evaluations here. We have imported classification report confusion matrix. From the documentation of confusion matrix here, like confusion matrix, it evaluates the accuracy of classification. So we will give in the true value, which is our test data, and y predicted, that is the one predicted by our model. So it will give an accuracy of the classification, and we get these values. Like we are still getting 92%, but we have just put the value k equals 1. So if the k value is 1, it will still lead to some sort of underfitting. Like it doesn't make much sense to classify it into just one cluster. So for choosing a k value, so here I have initiated a list accuracy rate, a list. Then we can set the values of k from 1 to 40, and for each value that is here in the for loop, we have put a neighbors equals I. That is, it will run from 1 to 40, and for each we will be storing the score accuracy rate here in the list. Similarly, like we can just calculate the error rate, that is just simply 1 minus the score min. And similarly, we can also use the mean and get a similar result. So like we can use either one of these, and we can plot it here. So here I have plotted the accuracy rate. Okay, sorry, this is supposed to be accuracy rate. So we have the accuracy rate graph here, and we can see that clearly we have the highest one at let's consider this one. I think it's almost the same with this one. So this is at 32. So if we run the KNN with k equals 32, then we have the following report, which is 93%, which is better than the one that we have got previously. So this one will be our optimum value of k. So that is how we implement KNN here.